The same circuit I have drawn here, the previous circuit, and the two equations we got it from the previous discussion. I have written it here separately. Then we can find out the values of V1 and V2 by elimination process. Let us say we can eliminate V1 because there is a positive 3V1 here and negative 3V1 here. Suppose we add these two equations, this will get cancelled and this will be 4V2 which is equal to 80. So, we find V2 first, this is 20 volts. Therefore, V1 will become 13.33 volts. This is one method, elimination method. The second method is the Cramer's rule method. What we do is, we represent these two equations in the matrix form. The coefficients we have written here, this is the coefficient matrix. 3 we have written here, minus 1 we have written here, minus 3 we have written here, and 5 we have put here. These are the variables to be found out, and this is the constant matrix. 20 and 60 is the constant matrix. You can directly invert this and find out V1, that is one solution, or we can find out with this rule. What we do is, first of all we find out the determinant of this coefficient matrix, which is 3 minus 1 minus 3 5. These two we multiply 15 and these two we multiply with a minus sign, that is why it is 3. So, the total value is determinant of this coefficient matrix is 12. Then the solution how we find for V1 is, we replace 3 and minus 3 with 20 and 60 here and find the determinant of that. So, we get delta 1. Delta is the determinant of this particular, that which is equal to 12. So, we can find out V1, and to find out V2 we remove this and put 20 and 60 here and find the determinant value. We get the determinant value here, and then coefficient determinant we will get it as 12. We have previously found out this. So, we can find out V1 and V2. So, there are two methods, elimination method or Cramer's rule. Which is best? It is up to you. If it is very simple and if it is obvious to find out V1 and V2 with elimination method, usually use this. And this is a systematic way of doing this. You can use a computer to find out V1 and V2. So, sometimes you use this, sometimes you use the elimination technique. Let us take a more complex circuit consisting of a current source, and a dependent current source, and more number of nodes. Earlier we have taken 2 nodes, now we shall take 3 nodes, V1, V2 and 3, apart from the datum node or reference node. Now, the technique is the same, whatever may be the circuit. So, for instance, we have 3 nodes here, we have 3 equations. That means, we apply Kirchhoff's current law at the 3 points 1, 2 and 3. Let us take a complex circuit consisting of an independent source 3 ampere source, a dependent source 2 Ix, and then instead of 2 nodes, now we have taken 3 nodes V1, V2 and V3 apart from the reference node. Now, we shall write the Kirchhoff's current law equations at the node 1, node 2 and 3. We get 3 equations and we simultaneously solve all the 3 equations, so that we get the values of V1, V2 and V3. Let us see at the node V1, what are the currents that are coming in and what are the currents that are going out. The currents that are coming into the node are 3 amperes, currents going out of the node are I1 and Ix. That is why at this node 1, the Kirchhoff's current law is 3 equal to I1 plus Ix. Now, we shall represent this I1 in terms of the voltages. So, I1 is the current flowing here. That means, this is at a higher potential than this. So, this is V1 by V3 by 4 is the current flowing in this particular branch. Then, what about Ix? Ix is the current flowing in 2 ohms. V1 is greater than V2. So, this is V1 minus V2 by 2 ohms. So, I1 is this and Ix is this. Similarly, we shall write the Kirchhoff's current law at node 2, and let us see what are the currents that are coming in and currents that are going out. Currents that are coming in are Ix, currents that are going out are I3 and I2. So, that is why this is the equation, Kirchhoff's current law equation at node 2. Likewise, we shall write the equation for node 3. So, what are the currents that are coming out? The currents that are coming out are this 2Ix. What are the currents that are coming in? Coming in are I2 and I1. That therefore, at node 3, it is I1 plus I2 equal to 2Ix. We shall represent these currents in terms of the voltages using Ohm's law. I1 is V1 minus V3, V1 minus V3 divided by this 4 ohms, plus I2 is V2 minus V3 by 8, V2 minus V3 by 8 ohms. This is equal to 2 into Ix. What about Ix? What is the current Ix? Ix is V1 minus V2 by 2 ohms. So, that is how we get the 3 equations, 1, 2, 3 equations, and we have written in the normalized form. So, we have written 3V1 minus 2V2 minus V3 equal to 12 is the simplification of this equation, and this equation is simplification of this, and the simplification of the third equation is this. Now, we shall see how we can find out the voltages of V1, V2 and V3. Same equations I have written here again, and then we can solve these simultaneous equations by elimination technique or by Cramer's rule. For instance, in the elimination technique, we first of all can eliminate V3. Suppose we add these two equations, then plus V3 and minus V3 becomes 0. So, there will not be any V3, you have an equation in terms of V1 and V2. Suppose you take first equation and second equation, you deduct one from the other and V3 is again eliminated. You have 2 more equations in terms of V1 and V2, and then we can simultaneously find out the solution of those 2 equations, and then you can do it, and you will find that the solution by elimination technique is V1 equal to 4.8 volts, V2 equal to 2.4 volts and V3 equal to minus 2.4 volts, which says that means we have analyzed the network, we found out the values of V1, V2, V3. With that we can find out the branch currents, with that we can find out the power, and we can find out the energy. Or the second method of solution of the simultaneous equation is by Cramer's rule. Just now we have seen how it can be worked out. So, first of all, we put it in the matrix form. The coefficients of V1, V2, V3 are put here. This is a coefficient matrix. For instance, if you look into the first row, this will be 3, minus 2 and minus 1. And this will be minus 4, 7 and minus 1. So, likewise you have 2, minus 3 and 1 for the third row. These are the values to be found out, V1, V2 and V3, and this is the constant matrix 12, 0 and 0. So, in the Cramer's rule, the first step is to find out the determinant of this value, coefficient matrix. So, first we shall find out the determinant of this. Next, we will find out the determinant by replacing these 3 things with the constant matrix for V1. So, V1 is delta 1 by delta, which is equal to 4.8 volts, same thing. Likewise, we replace 1200, these 3 elements with the 1200. So, we get V2, and finally, we will get V3 by replacing this minus 1 and 1 with the 1200 and finding out the determinant value. So, we will get the same value whether you are using the elimination technique or Cramer's rule.